Hello, calculus fans. Let's evaluate the limit as x approaches 0 from the positive side of log of cosine x and the limit as x approaches 0 from the positive side of log of sine x. It looks similar, but we're going to get very different results. Now for that first limit, we're going to introduce a new variable. Let's let t be equal to cosine x. So cosine x is just the inside part of this function. Now when x is near 0, cosine x is positive, and the limit as x approaches 0 of t, which is the limit as x approaches 0 from the positive side of cosine x, that's just going to be 1. So we can conclude that the limit as x approaches 0 from the positive side of log of cosine x is equal to the log of the limit as x approaches 0 from the positive side of cosine x, and that's log of 1. So we've established that this limit on the inside is just equal to 1, and so the whole thing is 0, because log of 1 is 0. Now we should note that our passage of the limit through the logarithm function is valid, and it's because the log function is continuous at x equals 1. Now our second limit is similar. This time we'll make a substitution to let s equal sine x, and when x is near 0 and x is positive, sine x is positive, and furthermore, we know that the limit as x approaches 0 from the positive side of s is the limit as x approaches 0 from the positive side of sine x, which is 0. And so we can conclude that our original limit as x approaches 0 from the positive side of log of sine x, is equal to the limit as s approaches 0 from the positive side of log s, because we've established that this limit is 0. So as x goes to 0, s goes to 0. And then this limit is negative infinity. The way that you can know that this limit here is negative infinity is to look at a picture of the log function. As the independent variable approaches 0 from the positive side, the y values are going to negative infinity. Okay, that's all for now.